Okay, so you have, the last thing you have is that each orbital has a different shape. So let's talk about the orbital shapes, and then we're going to fill in that table that I gave you yesterday. Okay, so there are 4 types of orbitals. There's the s orbital, and it is, we call it spherical in shape. It's the only one that's like a circle of all the orbitals that we're going to look at. So this is the, I'm going to say this is the simplest. And this would be 1. The second one is called the p orbital. And it is, they call it, I don't think it looks much like this, but the books call it dumbbell shaped. Which, you know, like the little hand weights you would use. After the p orbital is the d orbital, and this one is called 4-leaf clover shaped. And then the last one is the f orbital, and I'm just going to write complex. It doesn't even really have a name. So let me see if I can find one of these that you can actually see the picture on. So pull that handout out that I got, or I gave you yesterday, and you can look at it and get a little bit better idea like of what they actually look like and how complex they are. So S has this circle-like shape. Then the p orbital, that's what they're calling a dumbbell. And that dumbbell can be on any one of the 3, or is on each of the 3-dimensional axes. So there's not just one, there's actually 3 of those in a P. The D, this is the 4-leaf clover, which you can kind of see. Where do you see it best? Maybe here is where it best looks like a 4-leaf clover. 5 different orientations it can have. And then look at F. How do you even give something like that a name? You can't. So when you start, putting all these together, if I have a large atom, and I put all the orbitals together, I've got my circular orbital, and I would actually draw this, or try to draw it. And then I come in with my, I'm going to keep this the same color, then I come in with my dumbbell shapes, but there's one here, 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 and then I have to go up here. And then I have to come in with my, what's next after the dumbbell? 4-leaf clover. So now I start getting this bloop, 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 bloop in 5 different places. What does this equal? A mess. You can't clearly see the path. Now I should use something bigger than that. you know what I mean? Like, when you look at that and you think about all those things starting to overlap, you can't trace a clear path. You can predict probable location, which is exactly what we're going to do tomorrow when we start writing electron configurations. We're using all this information. It actually, by the time we get done, becomes very simple and easy to understand to figure out where the electrons most likely are in the atom. Now, I need to find one of these papers. I want you to go to, yeah, I have some extra ones. I have it written on. No, maybe not. Go to the page that's a table. Well, I see if I can find an extra one. Here's a couple. So let's look through this one. And let's see if we can figure this table out, because it puts all the information together for you. So this principal energy level, let's write above it. This is my principal quantum number. Now see if you can remember from yesterday. What symbol did we use for energy levels? N. So this is N. And we also said yesterday how many levels we were going to work with. Do you remember 1 through what? Anybody remember? Yeah. 7. So I'm going to go ahead and fill that in. 1, 2, 3, 4, 5, 6, 7. Then we're going to look at each energy level, and we're going to see how many sublevels they have with orbitals. And it's very simple, very set pattern. This is what I'm talking about when I say, think about that like the shape. And then let's think of the types of sublevels as like, how many, I'm trying to think of a good way to describe this. How many directions? Like when we look at this first picture, wherever it is, we've got 1. When we look at P, we've got 3. When we look at D, we've got 5. F, we've got 7. And then this one's pretty self-explanatory. So if I'm in the first energy level, I have 1 sublevel. If I'm in the second, I have 2. If I'm in the third, I have 3. If I'm in the fourth, I have 4. How many possible sublevels are there? How many letters did we just assign? The simplest was S. If you don't know, look in your notes. We just wrote it down. What you got, Caitlin? Okay, so there are 4. So by the time we get to the 4th energy level, we're using all the sublevels. So it doesn't change. It stays the same all the way down. Okay, so now I want you to look at the first sublevel is 1S. For 1 orbital. Now Now, some things we need to know about the orbitals. First of all, they're the place that holds the electrons. So that's like where the electrons sit. You can think of it that way. And they're represented by just a line, like a fill-in-the-blank line. So I don't try to draw S, I just make a line. When I get to the second energy level, it has two orbitals. We always start with the simplest. Now, what's the simplest orbital? S. So I have a 2s, which has one orbit, right? It only goes around one way. What's after S? P? It's a good thing you're here today, Haley. And I have 2p. Now look at that picture again. How many directions do I have rotating in P? Kyle, tell me when you find it. Good. So I have 3. Okay, now I'm going to go to the third energy level. It has the simplest, the 3s, with one orbit, or one orbital. It has the 3p, because it has 3 sublevels. So that's 3 orbitals. What comes after p? Adam? D. So we have a 3d. And then, Connor, how many different orbitals or shapes does D have? 5. So here I have 5. And then I get to my fourth energy level. I'm moving farther and farther away from the atom. So as we go down, the atom gets bigger because we have more electrons. That should make sense. When I get to the fourth energy level, I still have to start with the simplest orbital. I have a 4s with one orbital. I have a 4p with 3 orbitals. I have a 4d with 5 orbitals. What do I have next, Marty? What comes after D? F. I have a 4f. Tayden, how many different directions does F have? 7. So I have 7 orbitals. Do I go any farther than F? Is that the end of the shapes? Yeah, so it's going to stay the same all the rest of the periodic table. I never go past the F. I could have 5 S, P, D, and F, or 6 S, P, D, and F, but I can't go past the F. Now I'm also going to tell you, and we're going to write this up here, each orbital can hold 2 electrons. And that tells us the maximum number of electrons we can have in each energy level, if I calculate it. So if I look at the first energy level, I only have 1 orbital. If I only have 1 orbital, I only have 1 place to put electrons. How many electrons can each orbital hold? 2, which means my first energy level can only ever hold 2 electrons. I forgot to tell you this, but pull out your periodic table. The one that you write all your stuff on. Maybe I can find one. Yeah. Now, I want to see if you can do this. I want you to use your periodic table, and I want you to figure out which elements on the periodic table only have one energy level. Which elements only have one? When you think you have it figured out, stand up. Which elements on the periodic table only have one energy level? And if you can't figure it out, it's okay. We're going to talk about it. But you're going to have to figure out the next one. Forget what I asked you. Oh, which elements? I asked you elements, not which period. Noah, tell me one of the elements.
Hydrogen.
Hydrogen. Lexi, tell me another one. Helium. Stay standing if you agree with that. All right, now. Evan, tell me how you figured that out.
Well, I was originally when I was looking at it, I was just looking at the whatever the numbers on like the top of them are called. But then I saw that helium's 18, so I don't know.
Okay, so what does the number of electrons tell me on the periodic table? It's not the definition of it, but it tells me it because everything's neutral on the periodic table. Jackson.
The charge.
It tells me the charge. What else does it tell me, though? Yeah. Not neutrons. What's the definition of atomic number, Adam? I just changed the quote.
Atomic number. The definition of the atomic number is the number of protons.
The number of protons, and because everything's neutral, it's also the number of what, people?
Electrons.
Electrons. So I know I have 2 electrons. So I look for my element's atomic numbers. 1 would have the first electron, and 2 would have the second. Listen to that, because you're going to see a quiz really soon. 1 would have the first electron, that's hydrogen. Atomic number 2 would have 2 electrons, that's helium. Does that make sense when you look at the periodic table? Okay, sit down. We'll try another one. I want to make sure you get it. All right, so when I come to this 2s, 2p, I have to think of them individually. 2s, all s's, can only hold 2 electrons. What about p's? There are 3 orbitals here, or 3 spaces that can hold electrons. So how many total electrons can p hold? How many total electrons could the p orbital hold? Adam, what do you think?
6.
He said 6. Was anybody else thinking 6? Does anybody not know how he got that? Be honest. No? We're good? So we have 6 electrons here. 3. There are 3 of them. Each one can hold 2, so it's a simple 3 times 2. How many total electrons can the second energy level hold? What, Tayden? 8. He just added them together. He's right. So my second energy level can hold 8. Now I want you to find the element on your periodic table. See if you can do this. The element on your periodic table that has both its first and its second energy level full. Element on the periodic table that has both its first and second energy level full. Find it. When you have found it, stand up. Well, that was way quicker. Marty, what is it? Does oxygen have its first and its second energy level full? I mean. Let's add this up. First has 2, yes. Second has 8. How many total electrons is that? 10. What has atomic number 10? Neon. We were almost there. You were just looking at the second energy level, I think. All right, let's try the next one. Hey, what period is neon in? Not what group. It's in group 8A or group 18. What period is it in? Periods go across. Thank you, Noah. It's in the second period. Okay. Now let's look at this. Doesn't change. S orbital holds 2 electrons. P orbital, 3 times 2, holds 6 electrons. D orbital has 5 positions for electrons. So how many total electrons can it hold? I don't know, what is that? That's 6. I should write that down. That's 10, isn't it? So in the third energy level, total, I have 18 electrons. I'm just adding them together. Now, find the element on the periodic table that has its first, second, and third energy levels full. Getting better at it. What do you got, Haley?
Iron.
Iron? Do you agree with her? How many electrons is this? 18 plus 10 is 28. Is iron element 28? What is? Nickel. Okay. Sit down. Let's try something different. Well, we'll try the fourth one, and then if we're still not getting it. Did you just add wrong?
Yeah.
You forgot to add the 2. Did anybody else do that? Remember, if I'm talking about an energy level, we have to add all the ones that come before it, too. All right, so here's what I want you to do. Let's see if you guys can fill in this column over here with the number of electrons. Find the total number. So you're going to have to look at each one, figure out how many electrons it holds, and then total them up. When you've got it, stand up. Okay. Tell me how many electrons are in 4s, Riley. Okay, 2 electrons. How many electrons are in 4p, Evan?
6.
6 electrons. How many electrons are in 4d, Jacob? 10 electrons. How many electrons are in 4f? Who have I not heard from? Ty. 14 electrons. How many electrons total is that, Brooke? 32 electrons. Anybody have a question about how we got that? All right, sit down. Move to your lab partner. Take a periodic table with you, maybe in one sheet of notes. We'll do this quickly. Move, move, move. You don't have to take all your stuff. Just this little table will help you, and maybe your periodic table. Now I want you to do this together, and I want you to talk about it. I want you to find the element that has all of the first 4 energy levels full. What element has all of them full? And if you still don't know how to find that, call me over. When you find it, come put it on the board. Really find it though, and don't be afraid to write down different elements.
I got it.
It's the only way we're gonna know if everybody's got it. Did you, Kyle? I gotta get you a marker. That's a chemical symbol, you don't need to spell it. And it's lovely. Yeah, very nice penmanship. Penmanship.
Yeah.
Okay, come back, people, come back. Come back to your desk. And look at that! You all got it! Yeah, what would you do if I said nobody got it? All right, so look at this. Once I get past the fourth energy level, I don't have any more orbitals to add, so everything from here on down stays at 32. Nothing more to add. Now, pull up your periodic table, because we're going to write something on it. We're going to add something to it. Mine doesn't have a bunch of stuff written on it like yours, but you should be able to look at yours now and remember that the group number, what did the group number tell us for everything except what's in the middle? Jackson? Yep. How many electrons were in the outer shell? Now, if I look at this, and I look at the periods, like this is period 1, 2, you might want to write these in, 3, 4, 5, 6, 7. These guys fill in up here, so technically this is period 6, this is period 7. The period number tells the energy level that the atom ends in. We're just going to leave it at that for right now. Okay, so the next thing that I want you to do, and I want you to do this with your lab partner, I want you to grab a Chromebook, and I have 3 rules written on the board that apply to this stuff that we're going to use tomorrow. Off-ball principle, Pauli exclusion, and Hund's rule. I want you to search those 3 things. It won't take but like 5 minutes. Explain it and then leave some room. Explain the next one, leave a little room. Move. Grab a Chromebook. You really probably could do it with 1 Chromebook per group. So you're looking for the off-ball principle, Pauli exclusion principle, and Hund's rule. They're super easy to find.
Do we just write it in our notes?
Put it right in your notes. Yeah, just leave a little space between each, because I'm going to add a little bit. quickly.
Mrs. Beal,
Yeah,
just fair warning, my computer's going very slow, so it might take us.
is it really?
Yeah,
Are they still spinning?
It says please wait.
Oh, shoot. I don't like when that happens. Are you okay? You guys are on?
I'm in.
How many of you are in? Okay. Well, you just try, and if not, you'll just have to get them when we talk about them. Were you able to log on to that one? Okay. Raise your hand if you're working on poly exclusion. Okay.